How to assign formal charges to atoms. The learning goals are as follows. Upon completion of this video, you will be able to understand the relevance of formal charge, as well as understand the basic science of formal charge. That is, you will be able to define formal charge and calculate formal charge. Formal charge is relevant and important to chemistry because it allows for monitoring an atom's electrons and predicting its reactivity and molecular structure. A molecule can have more than one possible molecular structure, but the most likely structure is the one wherein all formal charges of atoms are zero or as near to zero as possible, wherein adjacent formal charges are zero or of the opposite sign, and wherein negative formal charges are on the more electronegative atoms. In this way, formal charge is considered when predicting molecular structure. Formal charge is the hypothetical charge of an atom in a molecule if electrons and bonds were evenly distributed between atoms. Formal charge is calculated with the equation formal charge is equal to the number of valence electrons in the neutral atom minus half the number of electrons in covalent bonds minus the number of electrons in lone pairs. I think it is easier to conceptualize formal charge if the equation is rewritten as formal charge is equal to the number of valence electrons in the neutral atom minus both half the number of electrons in covalent bonds and the number of electrons in lone pairs, to reinforce that the number of valence electrons around the atom in the molecule is being compared with and ultimately subtracted from the number of valence electrons in the neutral atom. Only half the number of electrons in covalent bonds are accounted for within the equation because formal charge is the hypothetical charge of an atom in a molecule if electrons and bonds were evenly distributed between atoms. In other words, electrons are divided equally between the two atoms in a covalent bond, so each atom contributes exactly half of the shared electrons. When calculating formal charge, it is important to remember that Lewis structures represent two shared electrons in a covalent bond with a line, and lone pairs of electrons with two dots. Also recall that the number of valence electrons in the neutral atom can be determined by the neutral atom's periodic table group number, barring transition metals. It should also be noted that the sum of the formal charges of all atoms in a molecule must be zero or equal to the charge of the ion, if an ion, and this can be utilized to check work. A worked example of assigning formal charges to each atom in ICl4-. Gather all necessary information to use the equation. Iodine is in group 17, so a neutral iodine atom has 7 valence electrons. Iodine has 8 electrons from 4 covalent bonds with chlorine atoms and 4 electrons in lone pairs. Its formal charge in the ion is -1. Chlorine is in group 17 too, so a neutral chlorine atom also has 7 valence electrons. Each chlorine atom in the ion has 2 electrons from 1 covalent bond with iodine and 6 electrons in lone pairs. Each chlorine atom in the ion has a formal charge of 0. The sum of the formal charges of all atoms in the ion can be found by multiplying 0 by 4, since there are 4 chlorine atoms with a formal charge of 0 in the ion, and adding -1, the formal charge of iodine in the ion. The sum is -1, which is equal to the charge of the ion, so the calculation is correct. Important concepts. Formal charge allows for monitoring an atom's electrons and predicting its reactivity and structure. It is the hypothetical charge of an atom if electrons were evenly distributed, and it is assigned by subtracting the number of valence electrons around the atom in the molecule from the number of valence electrons in the neutral atom.